Every single day, we perform a dozen unconscious physical handshakes with the very buildings we live and work in. We push, pull, and turn the brass and steel that guard our most private spaces. This is architectural hardware. It is the mechanical backbone of our built environment. The hinges, handles, locks, and closers that physically separate rooms and secure our borders. For centuries, this industry relied on a static logic. A lock was a passive metal fortress. If you wanted better security, you didn't make the lock smarter. You just forged thicker steel and heavier tumblers. But that logic has collided with how we live now. We manage our bank accounts, our schedules, and our social lives through the cloud. Yet we still secure our physical doors with the exact same mechanical pins and levers used in the 1800s. The demand for connectivity forced the market to pivot. Manufacturers are now integrating electronics into every latch and hinge, scaling this industry toward a valuation of over $115 billion. This shift relies on active intelligence, the transition from physical keys to biometric sensors and IoT connectivity. IoT, or the Internet of Things, refers to devices embedded with sensors and software that connect and exchange data over the Internet. This chart illustrates the scale of that adoption. In 2023 alone, global shipments of sensor-based smart locks reached 18 million units. But digital security is only half the equation. The events of the last few years exposed biological vulnerabilities. Maintaining hygienic public infrastructure through manual sanitization with hazmat suits and power washers is labor-intensive and difficult to scale across a city. The industry's solution comes from material science. Engineers are integrating antimicrobial copper alloys directly into door handles and push plates, creating surfaces capable of eliminating 99.9% of bacteria within 2 hours of contact. These self-cleaning materials have moved past the testing phase. They are now standard deployments across hundreds of healthcare facilities in France, Germany, and Spain. Modern hardware functions as more than a physical barrier. It has become an active participant in building management and human health defense. How this technology rolls out depends on geography. In North America and Europe, the primary focus is upgrading the existing built environment rather than constructing entirely new cities. This drives a renovation wave. When homeowners upgrade their kitchens and bathrooms, they replace dozens of obsolete fixtures at once, making these rooms the densest entry points for intelligent hardware. Beyond consumer demand, top-down regulatory pressure forces the issue. Regulators passing strict environmental mandates, like the European Energy Performance of Buildings Directive, require new benchmarks for energy efficiency that older hardware cannot meet. Manufacturers have responded by overhauling their supply chains. They increasingly utilize recycled metals and low VOC finishes. VOCs, or volatile organic compounds, are harmful chemicals that slowly off-gas from paints and coatings into the indoor air. A simple bathroom remodel quietly strips out obsolete materials and upgrades the West's aging infrastructure into an interconnected, sustainable grid, one hinge at a time. While the West remodels, the Asia-Pacific region is building from scratch. This area has become the high-volume epicenter of the architectural hardware boom. This map visualizes the volume of that growth. By capturing over 36% of the global market share, the APAC region was the primary driver behind the 1.8 billion square meters of new construction completed globally in 2025. Rapidly urbanizing nations like China and India are bypassing the retrofit phase. As they raise new megacities, developers natively integrate smart hardware into the infrastructure from day one. This compounding demand, retrofits in the West, and massive new construction in the East, is propelling the industry forward. The market is tracking an explosive compound annual growth rate, or CAGR, toward an estimated $115.8 billion by 2034. By integrating access hardware with building management systems, companies like Siemens and Dormakaba are turning door locks into sensors for the entire building. A single biometric scan at the door can now trigger a chain reaction, adjusting the HVAC, the lighting, and the occupancy data for an entire district. Touching a door lever today is a physical interaction with a $115 billion shift in how we inhabit the planet. It is the moment where human touch meets a global network of smart, sustainable infrastructure.